Okay, so now I want to recall that the following are equivalent. Okay, so the derivative of a function f at x equals a is the same thing as the slope of the tangent line to the graph of a function f at x equals a, which is the same thing as the instantaneous rate of change of a function f at x equals a. Alright, so all of these three things are the same thing. So you want to just make sure that you have this engraved. When I say to you the derivative of function at x equals a, you want to be like, okay, that's the slope of the tangent line to the graph of the function f at x equals a. And it's also the instantaneous rate of change of a function f at x equals a. Alright, and so you want to remember when we're talking about tangent lines to a graph of a function, that's just a line going through one point for the graph of the function, whereas a secant line is a line going through 2 points for the graph of the function. Alright, so you want to make sure that you understand the difference between a tangent line and a secant line. Alright, secant line going through 2 points on the graph of the function, whereas a tangent line is a line going through 1 point to the graph of the function f. Okay, and so we said that the slope of the tangent line to the graph of the function f at x equals a is the derivative of the function f at x equals a. Now we also knew that from the average rate of change lesson that the slope of the secant line is the same thing as the average rate of change. So the slope of the secant line going through 2 points is the same thing as the average rate of change between those 2 points. Okay, and so that's the relationship. There's a lot of terms here going on with interpreting and like what is the derivative. So you want to make sure that you have these terminologies set and straight. Okay. So now how is this definition where I know the derivative of a function f is the slope of the tangent line to the graph of the function f going to come into play? So when you're looking at graphs, this is pretty much where it comes into play because that's the graphical definition of the derivative, is the slope of the tangent line. So here when I'm looking at this graph and I want to use this graph below to order the derivatives at the following points from least to greatest, I need to consider the slope of the tangent line going through these points. Okay, and so now at this point you might be like, all right, well, how do I draw a tangent line to a point? Well, basically what you want to do is you want to look at the point. So see if I want to draw a tangent line to the point at A, labeled A here. If I'm going to draw a tangent line, I want it to go through that point, and I also want it to kind of follow the graph. Okay, but remember that the tangent line is a line going through only 1 point for the graph of your function f. Alright, so it's following the graph kind of, but it's not going through any other points other than that point. Okay, the same idea here with your point B. So you want it to follow the graph, but again, it's only going through that point B. Same thing with C. Same thing with D. Same thing with E. And then same thing with F. Okay. And so the reason why I'm drawing these tangent lines is because I'm interested in the slope of these tangent lines, all right, because I want to know ordering the derivatives, from least to greatest. How do I do that graphically? Well, I look at the slope of the tangent line and I figure out which slopes are biggest and which slopes are smallest. All right, and that will tell me where the derivatives are biggest and where the derivatives are smallest. Okay, so here, looking at points A, C, and D, we see that we have horizontal tangent lines. All right, and so this is kind of going back now to algebra where you learned the slope of a horizontal line. All right, so the slope of a horizontal line is 0, okay? And so then that means that the slope of the tangent line, so I'm going to denote that m tan, okay, is equal to 0 at points A, C, and D. Okay, and so I'm just going to say, since they have horizontal tangent lines. Okay. And so what does that mean in terms of the derivative? Well, then that means the derivative at A is equal to 0, the derivative at C is equal to 0, and the derivative at D is equal to 0. Okay, because I know that the slope of the tangent line going through those points is 0, which means that the derivative at those points is 0. Okay, so you want to get that engraved into your mind. Okay, so now I don't know exact values for these remaining points here, okay, because I just have, you know, these lines and it's very arbitrary. But what we do know is whether or not the slope is positive or negative, like just looking at them. And we also know kind of like the steepness, right? So here when I look at the slope of my tangent line going through for point B, I know that that's going to have a positive slope because that line is pointed to the right. So here, if you think about this, if you just have a line going like this, where your graph is like x and y, alright, the slope of this line is pointed to the right, and so this is going to be a positive slope. Okay, whereas if you have something like x and y, and you have a line going like this pointed to the left, that means that the slope of that line is negative. Okay, so here I'm going to say, well, then I know that the slope of my tangent line is positive at point B. Okay, and so in terms of the derivative, that means I know that the derivative, the derivative at my point B is greater than 0, or in other words, it's positive. Okay. And so now you want to look at the slope of the tangent line going through the points E and F. And so what you might notice is that both of those lines are pointed to the left, which means that the slope of the tangent line is negative for both of those points. So here, the slope of the tangent line is negative at points E and F. So then that means that the derivative at point E is less than 0, and the derivative at point F is less than 0. Okay, and so in other words, that means it's negative. Okay, so now here's the big question here. You might be like, okay, but how do I know which one is bigger in terms of the derivative at E and the derivative at F? I know both of them are negative, right? And so this is the part where you want to look at the steepness, okay, of the line. So if you think of it like this, so you have a graph again, and you have your x and y axis, and say I graph something like y equals 1/2 x, and then I graph something like, y equals 2x. Okay, and so you can physically see this if you put in like these two things into Desmos, okay? But the idea is here is that the bigger your number is when the slope is positive, the steeper your line is. Okay, and so you would say that y equals 2x has a bigger slope than y equals 1/2 x, because numerically you can see that like 2 is bigger than 1/2. But looking at the graph, you just know that this line here is going to have a bigger slope because it's steeper. Okay, well, that's the case for when you have a positive slope. Let's see if you have like a negative slope. So let's like look at that and consider that. So here I have that this is going to be look at if I have this is x and this is y, and say I want to do this is giving me y equals negative 2x, and then this other one here is y equals 1/2 x, negative 1/2 x. Okay, and so the steeper the line is, the more negative your number is. Okay, so I know that negative 2 is less than negative 1/2. Okay, and so if I have a steeper line and my slope is if I have a steeper line where my slope is negative, so if my steeper line is pointed in the left direction, then I know that that's less than the negative slope that's just not as steep. Okay, and so looking back at the tangent lines for points E and F, it might be hard a little bit to tell the way I graph these tangent lines, but the idea here is that at point F, that tangent line there is steeper than the tangent line at E. And so when I'm trying to compare these slopes, I'm going to know that the slope at point F is going to be less than the slope at point E because the slope there is negative and that line is steeper. So I'm going to put here that the derivative at F is less than the derivative at E because the slope of the tangent line at point E is negative and steeper than at point E. Okay, so you notice that both of these slopes again are negative, but the fact that the line is steeper at point F tells you that that slope is going to be less than the slope that's not as steep, and that's for the negative direction, because again, that's not true for the positive direction. When you look at this graph over here, we know that if the slope is positive and has a steeper line, then that's going to be the biggest slope. Okay, because here you'd be like, okay, well, 2 is clearly bigger than 1/2. Okay, and so now if I want to order these from biggest to smallest, let's do that. So now, ordering these from biggest to smallest, I'm going to have that my biggest one is going to be the derivative that's positive. All right, so I have that f prime of b is the biggest. Okay, and then from there, I have that the derivative at a, the derivative at c, and the derivative at d are all 0. And so, sorry guys, I'm going to have to erase this graph, but hopefully we understand. So I just ran out of room here. So this is the derivative at b is bigger than the derivative at a, which is equal to the derivative at c, which is equal to the derivative at d. And so we know that the derivative the derivative at e is bigger than the derivative at f. And so we have f prime of e is bigger than f prime of f. Okay, and so that's our ordering.